to talk about conservation of energy. It is one of the most important and beautiful theorem in physics. Conservation of energy tells us you can never create, or nor can you be ever able to destroy energy, but you can transfer energy from one form to the other form, from potential to kinetic and kinetic to potential. I want you to consider these three objects, right? And I also want you to consider three properties of these three objects. One is mass, all right? These three objects have same mass, okay? This is Einstein bust, they have the same mass. These three objects also have the same height because they are all sitting on the desk and they have the same height. And also these three objects have the same acceleration due to gravity acting on them, and that is negative 9.8 meter per second squared. So these three objects have same potential energy because gravitational potential energy depend on mgh. Their m is the same, okay? Their m is the same, their acceleration due to gravity is the same, okay, and their height is the same. However, now this should be different, right? Now this one has more potential energy than this one, and finally this one has no potential energy because this one height is 0, right? Okay, so now if I give you the mass is 10 kilogram, so then potential energy over here is 0 joule, potential energy over here also is 0 joule, and potential energy also over here is 0 joule. How here is 2000 joule. Kinetic energy over here is 0 joule. All right, so what is the total energy? Total energy over here is 2000 joule. Okay. Very nice. What about over here? Potential energy is 1000 joule. Kinetic energy over here is 1000 joule. Total energy is 2000 joule. What does that mean? Conservation of energy whole. What about over here? Potential energy is 0. However, kinetic energy is 2000 joules. So total energy is 2000 joules. I'm going to quickly show you how all the potential energy become the kinetic energy. All right. How? Okay, let's see. D is equal to VAT plus half AT squared, right? And D is negative 20. VIT is 0 minus 5T squared. Why is that? Because acceleration due to gravity is negative 10. So then you have 5, you have T squared is equal to 4. So you have T is equal to 2. All right. With that, you can find the velocity. Velocity is, so velocity is 10 times 2, which is 20. With that, you can find the kinetic energy. How? Kinetic energy is half mv squared. So half m is of course 10 and 20 squared. So 2000 joule. That's how all potential energy over here become kinetic energy over there. Okay, now let's dive in. We're gonna make the case a little difficult and interesting, and let's see how that goes. Mass 1 is 4 kilogram, and mass 2 is 6 kilogram. Mass 2 is 2 meters above the ground. We're going to do the same thing. This is t is equal to 0 second. And this is t is equal to t second. What is t second? We're going to find it out. Now, instead of this one is on the ground, this is 2 meters above the ground. Mass 1 is 2 meters above the ground, and mass 2 is on the ground. Okay. First, we're going to find the acceleration. Before even finding the acceleration, what are we going to do? We're going to make some hypothesis. We're going to cut this in half. We're going to say that hypothesis number 1, our main goal is energy before is equal to energy after. Okay, energy is conserved. This is before, This is after. So energy before is equal to energy after. That's what we're gonna. So conservation of energy hold. By the way, conservation of momentum will not hold over here because this is not a closed system. Okay, this is one of the example where the conservation of momentum will not hold because this is not a closed system. Okay, so we're gonna cut this in half. If we do cut this in half, we're gonna say tension force is more than force due to gravity. Work done by tension force is more than work done by gravity. So the person will feel heavier over here. On the other side, Fg is bigger than tension. So work done by gravity is bigger than work done by tension. So the person will feel lighter. Okay, so the first thing we're going to find is acceleration. To find the acceleration, what we're going to do is we're going to write mass 1 and mass 2. Mass 1, we know there are two forces acting. All right, one is x, both of them y direction. Nothing is at the x direction. So this is our Fg, which is m1g. This is our Ft. Okay, and again, two forces acting on it. This is Fg, which is m2g, and this is Ft. Notice that for both cases, the Ft is positive and Fg is negative. However, the three conditions, three hypotheses, three rules, I'm going to give you rule number 1. If force act at the direction of the displacement, then positive work done. Positive work done. If rule 2, if force act opposite to the direction of the displacement, negative work done. Rule number 3. If force act 90 degree at the direction of the displacement, zero work done. In this case, this is 0 degree, cosine 0 degree. In this case, this is cosine 180 degree. In this case, cosine 90 degree. Cosine 0 degree is 1. Cosine 180 degree is -1. Cosine 90 degree is 0. These three hypotheses will guide us to prove that conservation of energy hold. Okay? All right, so let's start our conversation with Newton's second law, F equal ma. If you write F equal ma, what do we see? We see Ft minus m1g is equal to m1a. The acceleration is positive, so I'm not going to change the sign. This one is F equal to negative m2a, y direction. Ft minus m2g is equal to minus m2a. Okay. Now, we can use the system of equation to isolate the acceleration, but we also can use the algebraic shortcut. If we say that Ft is equal to m2g minus m2a, and replace over here, Ft is equal to m2g minus m2a minus m1g is equal to m1a. Okay, we definitely can do that. So what that become? That become m2g minus m1g is equal to m2a plus m1a. So we factor out g, m2 minus m1. We factor out a, m2 plus m1. So acceleration is m2 minus m1 over m2 plus m1. So acceleration is g is you're going to use 10, m2 is 6 minus 4, 6 plus 4. So you see that 10, 2, and 10. So acceleration is 2 meter per second squared. Okay, that's the acceleration. Now we're going to try to find the velocity. All right, this is number one. And number two, you're going to find the velocity. Vf is squared, velocity final. What does that mean? What is the velocity of the m2 impact velocity? Let's say m1 impact velocity or m2 impact velocity. They both have the same velocity. Vf squared is equal to vi squared plus 280. So Vf squared is equal to 0, 2 times 2 times 2. So Vf is 2 root 2. I'm going to quickly find the time. Okay, the impact velocity, what time the impact velocity took place. So you already know the impact velocity. So the time would be what? Vf is equal to Vi plus At. Okay. So the t would be Vf over A because this is 0. Vf is 2 root 2 and acceleration is 2. So the time is root 2. So we exactly know what time it took place. 2 seconds. Root 2 seconds. And what time this one took place? T is equal to 0. Now, we're going to do it for mass 1 and mass 2 separately to prove that the energy conserved. So this is mass 1. The first thing we're going to show the work done by gravity. To do work done by gravity, you're going to do FGD cosine theta. Who is working? Gravity, FG. Okay. Mass 1 is 4 kilogram, remind you. So 4 times 10 is 40. D is 2, remind you. This is the direction of FG. This is the direction of D. Okay, they're opposite to each other. So rule number 2 tells us if they're opposite to each other, then negative work is done. Cosine 180. So what do you learn from here? You learn that our conceptual, our rule agree with the math. Our rule tells us if the force act opposite at the direction of the displacement, then negative work is done. And that's what we see over here. This is problem 4. Problem 5, Ft on mass 1. Ft on mass 1 is directly this one. If I put you in the box number 1, you will feel heavier. That means I'm going to use this one. Ft is equal to m1a plus m1g. So Ft is equal to m1a plus g. So Ft is equal to what? M1 is 4, A is 10 plus A is 2 plus 10. So 48. Okay, that's our Ft. Now, work done by tension force. Number 6. Ft cosine theta. Ft is 48, D is 2 cosine theta. Ft is up and displacement is up. Our rule number 1 tells us if both vectors are at the same direction, then positive work is done. So this is 0 degree. Okay, so this is 0 degree. So this is 96 because this is 1. Okay, 96 what? Joule. Number 7, we're going to see the net work done on box number 1. So the net work is work done by tension force but work done by gravity. So 96 minus, of course, 80. Right? So 16 joule. How much work done on box number 1? 16 joule. We're going to check whether that is correct. Number 8, we know kinetic energy is equal to half mv squared, right? So K is equal to what? Half, m is 4, v is 2 root 2 square. So K is equal to, this is 2, 2 times 4, which is 8, 8 times 2, which is 16 joule. So we prove that the kinetic energy acting on mass 1 is indeed 16 joule. Now, we're going to do more things. On M1. So let's say potential energy, momentum. This is problem number 9. Momentum. On M1, we're still doing M1. This is still M1. This is still M1, which is 4. Momentum is 0. Why is 0? Momentum right here is 0. If velocity is 0, momentum is 0. Momentum final, mv. Momentum final is right here. Okay, so momentum final is m is 4, v is 2 root 2, so 8 root 2. Okay, so you're going to find the impulse. Impulse is momentum final minus momentum initial. So 8 root 2. Okay, this is 10. So you're going to now find force. Force is impulse over time. So force is 8 root 2 over root 2. So force is 8. So we're going to verify whether that is correct. Force is actually 8 Newton. One way of verifying it, acceleration is force over mass. So acceleration is 8 over 4, so this is 2. Indeed, we found it before. Okay, so that is mass 1. Now we're going to do the same thing on mass 2. Okay, I'm going to erase this one to make some room for mass 2. So mass 2 is equal to 6 kilogram. All right. First, we're going to find the work done by gravity on mass 2. So 6 times 10, 60 times 2 cosine theta. If you look at mass 2, then what do you see? You see Fg is this direction and d is this direction. Both vectors are the same direction, so this must be 0. So this must be 1. Please agree with hypothesis number 1. When both vectors are at the same direction, positive work is done. So this is 120 joule. Now Ft is, the equation for Ft is over here. If I put you in this box, you're going to feel lighter. So that's the equation I'm going to use. Ft is equal to m2g minus m2a. Okay? All right, so let's see. Ft is equal to m2g minus a. So Ft is equal to m2 is 6, g is 10, minus a is 2. So Ft is 48. Again, we got the same thing. Ft is 48. This is 15. This is 16. 17. Work done by tension force is Ft d cosine theta. Ft is 48. Ft is this direction, and d is this direction. So this must be 180. So this must be negative 1. So work done by tension force in this case is negative 96. The other one was positive 96. This one is negative 96. So number 18, net work is 120 minus 96. So it's 24. We're going to check whether 24 is right by plugging in K is equal to half mv squared, and then K is equal to half 6 v is 2 root 2 squared, which is indeed 24 joule. Okay, now we're going to find the momentum. Momentum initial is equal to 0. Momentum final is equal to, here's the momentum final. 6, 2 root 2. So 12 root 2. So now is a good time to find the impulse. Impulse is 12 root 2. So then force is impulse over time. So 12 root 2 over 2. So force is 12. So acceleration is force over mass. So acceleration is 12 divided by 6, so 2. That confirms that acceleration is 2. 2. Okay. Now, as the most important time is to find that the conservation of energy holds. And how the conservation of energy holds, we'll see. So for mass 1, potential energy initial, potential energy final, kinetic energy initial, kinetic energy final. Mass 2, potential energy initial, potential energy final, kinetic energy initial, kinetic energy final. So, what is the potential energy initial? Oh, let's see. I'm going to make it a little bigger so you see the diagram. Potential energy initial is, let's use different color. We are doing the mass 1. So this is mass 1. Okay, look, height is 0. Potential energy final, height is not 0, so mgh. Kinetic energy initial, well, it is at rest, velocity is 0. Well, velocity is maximum. All right, let's do mass 2. Potential energy is, potential energy is not 0 because height is not 0. Potential energy final is 0 because the height is almost 0. Kinetic energy is 0 because the velocity is 0. Kinetic energy is not 0 because there is an impact velocity. Okay, so you're going to see that, you're going to see magic. This and this, we're going to add this. Okay, what is this? 0 plus 0, 0 plus 0 plus mgh plus 0 is equal to mgh plus half mv square plus 0 plus half mv square are the same. Okay, let's see. What is mgh over here? This is mass 2. 6, 10, and height 2. So this is 120. So let's put 120 over here. 0 plus 0 plus 120 plus 0 is equal to, mass is 4. This is 10. Height is 2. Mass is 4. Potential energy final. So this is 8. Let's see this one. Half. Mass is 4. V is 2 root 2 squared. This is 2. So 2 times 4 times 2. Short 16. This one is 16. This is half. This mass is 6. Velocity is 2 root 2. This is 3. This is 4. This is 2. This is 24. Okay, so now come over here. Update it. mgh is 80 plus 16 plus 24. So 120 is equal to 120. All right, so the other thing you learn that the kinetic energy gain over here, kinetic energy gain by 96 joule, kinetic energy lost by 96 joule. Okay. All right, so that's what the conservation of energy.